Good day, everyone. Thank you for being here today. My name is erammahamud. My student ID is 201153499, and I am excited to share my research on DenseNet COVID-19, a fine-tuned deep transfer learning method for classification of COVID-19, pneumonia, and tuberculosis from X-ray images. In a world increasingly dominated by technological advancements, understanding the profound effects of artificial intelligence and deep learning has never been more critical. At the beginning, we are going to discuss about the data preprocessing, where we have done the image augmentation first, then we have done the denoising autoencoder. If we go to the code, we can see we have done the image augmentation where we have done the augmentation by image data generator, which we have to define a path and it gathers the inputs like we have done the rescale, rotation, Y shift, high shift, shear range, zoom range, horizontal flip, and fill mode. So here we can see the original image and the augmented images here. After that, we have done the denoising autoencoder part, which is used to remove noise from corrupted inputs. Here we have declared the input directory and the output directory, and have the encoder part and a decoder part which decodes images, and after that the images are ready for classification. After on the denoising images, we have done the clay. Well, clay is used to enhance the contrast of an image by redistributing pixel intensities, particularly in areas with varying illumination, helping to improve visibility and detail in both bright and dark regions. Here we can see it's the same type of code where the file name ends with JPG and PNG, or else our images might misplace or something like that. After image enhancement, we have done the gamma correction on that output. Well, here gamma correction is used to adjust the brightness and contrast of images. Then we have experimented some pre-trained models. If we go to the code of the pre-trained models, here we can see the LeanNet model, which is at the fourth position because total accuracy we got is 91%. And the classification, if we go to the classification report, we can see a good confusion metrics and average precision, recall, and F1 score, which is good models. So I have placed it at the fourth position. After LeanNet model, at the third position, we can see the Inception B3 model because Inception B3 performed better than the LeanNet model. If we go to the confusion metrics, we can see that it performed and classified more images than the LeanNet model. Here we can see and here we can see the precision is 0.92, recall is 0.90, and F1 score is 0.92, and the overall accuracy here is 92 as well, which is better than the LeanNet one. And after the LeanNet, we have placed the Inception B3, and after the Inception B3, we have placed the EfficientNet B0, which performed better than the Inception B3 model. If we go to the code, we can see that the confusion metrics, it classified more than the Inception V3, and the overall accuracy here is 94%, which is more than the Inception V3 and LeanNet as well. So that's why we have chosen it as the second best model. If we go to the training and validation accuracy and loss, we can see that it performed better than the Inception V3 and the LeanNet model as well. And after that, we have our proposed model, which is DenseNet COV19, which is a modified model of DenseNet 201, because I have changed the layers after evaluation studies. We have found out better than the DenseNet 201. The accuracy which we have got with the DenseNet 201 model was like 96.12%. But after the fine tuning and the changing flattened layers and other evaluation studies have been made, I've made some customizations on the model, so we can say that our model is new. So it performed really well, which that's why the accuracy jumped from 96 to 98.80, and the validation accuracy is 99.46, and the training accuracy is 1. And if we see the confusion metrics here, we can see that it outperformed every single one of them. Here if we see a normalized confusion metrics, we can see the COVID-19 part is 99% detected, normal part is 98% detected, pneumonia is 99%, and tuberculosis is 99%. And the overall F1 score is 0.98%, and overall precision is also 98.80, and overall recall is 98%, and overall accuracy is 98%, which outperformed every single one of them. And after the mode on plot training and validation loss, we can see that the loss is nearly zero, and the training is better than any other models that we have used or trained. After that, we have on the evaluation study, if we go to the slide, we can see we have done the evaluation study. We have done also other experiments like GradCam result visualization. If we go to the GradCam visualization code, we can see codes that we can see that here we have done the GradCam visualization, and after that we have if we go to the slide, we can see we have done the lime and sharp result visualization. If we go to the code, we can see here it is the kernel explainer of sharp method, and if we go to the another code, we can see we have done the gradient explainer of sharp values, and It's the Lime code, which detects the difference between normal and disease images which contains diseases. After that, we have done the deployment. For the deployment part, I have converted my predicted model or classification model into a TF-like model, which classifies the diseases. Like, if we look at the mobile app accurately, we can see we have two buttons. At first, the button is called Take Pictures. If we press the button, then it will open a camera. The camera will take you. The camera will help you to take raw images, and you can take pictures with it, and it will classify the images. And after that, we have another button which calls Launch Gallery. In this Launch Gallery part, we can, if we press the Launch Gallery button, we go directly into gallery, and we can import pictures from here. And then if we select a picture, suppose I'm selecting a picture from classify or predict the required the exact disease. If we take another picture, for example, suppose I'm taking this picture, it will classify as tuberculosis. Uh, so that's all from me. Thank you, everyone. Assalamu alaikum.